The quantity P varies inversely as the square of V. V squared is in an inverse relationship with P. Because it is inversely related to P, then in any expression relating P to the square of V, then it is going to be necessary to write the multiplicative inverse or the reciprocal of V squared. And that is why it is written with V squared in the denominator, because the relationship with P and V squared is an inverse relationship. So we are talking about the multiplicative inverse, which will be the reciprocal of V squared. That is what we mean by the inverse relationship, or the inverse relationship dictates that we will have in the relationship the inverse, or in the equation or in the expression, the inverse or the reciprocal of V squared. Also, we have the constant of proportionality relating the two quantities. The second sentence in the statement of the problem says, given that V is equal to 3 when P is equal to 4, determine the positive value of V when P is equal to 1. Whenever a variation problem is given, initial values are also given with the intention that we will use them in finding the value of the constant of variation or constant of proportionality. So the constant of proportionality relates P to the square of V. Therefore, if we are given the value of P and we are required to find a corresponding value of V, then the constant of proportionality will play a vital role. It is important, therefore, that in the solution of any variation, whether it is inverse or direct variation problem, that we attempt to find the value of K first. Now, that is not difficult because every other variable or every other unknown is taken care of right here. So when we substitute V is equal to 3 and P is equal to 4, the only unknown will be K. The variation problem is therefore designed for us to acquire the value of K in the beginning, because that is going to be used throughout the entire process. It so happens that in this particular case, the process is short. V is equal to 3. Now we are attempting to find the value of the constant of proportionality, and it is given that V is equal to 3. Therefore, where we have V, we will substitute 3. Substitute 3 in the place of V. Also, P is equal to 4. Substitute 4 in the place of P. The only unknown that we have is K. And we have a single equation with a single unknown, then we know that we have a unique solution. Initially, what we will do is rewrite the expression with the value of 3 squared. Meaning that we need to write the equivalent of 3 squared, and 3 squared is equal to 9. The equation may be written with the value of 3 squared. So 3 squared is written as 9. 4 is equal to K over 9. K is the unknown in the equation. It is accompanied on the right hand side by 9, which is in a division relationship with it. We will therefore eliminate that 9 by multiplying by 9. K is our unknown. We need to find its value. We therefore need to eliminate this 9 that we have accompanying K on this right hand side. which is in a division relationship, we will need to do the inverse or the reverse of division, which is multiplication, or we just say the opposite of division, which is multiplication. Not just multiplication, but multiplication by 9. We therefore need to multiply by 9 on that right hand side. Also, what we do to one side of an equation to change its value must be done to the other side in order to change its value in the same way. And that is known as balancing the equation. So we multiply the right hand side by 9, we need to do the same on the left hand side. Balance the equation by multiplying by 9 on the left hand side also. What will happen? We will see that the simplification process takes care of the 9. We will cancel those 9s, and on the left hand side we have 9 times 4 will be 36. So on the right hand side, we have k alone, because k divided by 1 is k. Then on the left hand side, 9 fours 36. To write a symbol on the right hand side of an equation and a numerical value on the left hand side is a very dangerous thing. The equation is appropriately written with the numerical value on the right hand side. So we will rewrite that with the numerical value on the right hand side. Now students, it is not that it is universally unacceptable. It is quite okay as an intermediate step, but as a final answer, that is not okay. Now, you might not get the fullness of it. However, I will attempt to explain why. Now, what we are saying here by having 36 is equal to k, it means that 36 is equal to whatever k is. And we know that 36 can only be equal to 36. But under different circumstances, the value of k might change. So 36 as a final result cannot be equal to k. However, the value of k can be 36, because 36, although being a constant value, the value of k is subject to the circumstance. So k can be equal to 36. Because 36 is a single value, k can assume the value of 36. While we cannot say that 36 can assume the value of k, because the value of k might be different under different circumstances. I hope that you found that explanation quite useful. If not, do not worry. Later on, it will reveal itself more and more to you, and it will be clearer. Now that we have found the value of k, which we have found to be 36, we may proceed to find the value of v. Let's go straight ahead. K is equal to 36. And we are using the exact same equation, because once we have determined the equation which defines the relationship between P and V, then that equation might be used throughout the entire process of solving the equation. We do not have to have another relationship. We may just use that all of the time. Now K is equal to 36. Let's replace that K with the value of 36. Substitute the known value of K in its rightful place right there. What else do we know? Because we need to be able to find the value of V, and for us to find the value of V, V has to be the only unknown in the equation. V has to be the only unknown. There we have it again. The value of P is equal to 1. And this verifies what we said about the variation problem before, and that is the same irrespective of whether it is an inverse variation or a direct variation. We will always have 3 parameters, and the statement of the problem will make the provision that at every stage of the game we have the values of 2 of them, and our duty is to just find the other one. We have the value of k, and here we have the value of p to be 1. So we will no doubt substitute 1 in the place of p. P is equal to 1. V now is the only unknown, and we will solve the equation. Variation problems are simplified by the fact that there are only 3 parameters of which the values of 2 are always known, and our job is just to find the other one. Always 3 parameters, and we always have the values of 2. Now we started off with the values of p and v, which of course, although it was not said, we have to use those initial values to find the value of k, which is an understanding that every candidate should have. You have a variation problem. One of our first moves is to find the value of the constant of proportionality, because by so doing we will find the corresponding value of one variable as long as we have the value of the other. V is the unknown, because we are going to find the value of v now. V is the unknown. It is in the denominator on the right hand side. We may eliminate it from the denominator by multiplying by v squared. Now candidates, when we are solving an equation, a numerical value denominator is not the only thing that we might eliminate. We might also eliminate the unknown whose value we are trying to find. Because if it is in the denominator on the right hand side, it might be that it is not our suit to have it in the denominator. So we will eliminate it from the denominator. That's acceptable. We may also eliminate the unknown. But when we eliminate the unknown on one side of the equation, we will have an occurrence of that unknown on the other side. So it will not vanish from the equation entirely. Because if it is entirely vanished from the equation, we will not have any unknown. As a matter of fact, it is not possible for us to do so. So we have no difficulty eliminating it from the denominator on the right hand side. So we multiply by v squared on the right hand side. And do not forget that whatever we do to change the value of one side of an equation must be done to the other side in order to change the value of that side in the same way. So we need also to multiply by v squared on the left hand side, and that is known as balancing the equation. Multiply by v squared on the left hand side. So we have v squared cancelling v squared on the right hand side, which means that v squared is eliminated from that side, and on the left hand side we have v squared multiplied by 1 is equal to v squared. So on that right hand side, all that we have left is 36 to be divided by 1. Anything divided by 1 is equal to that same thing. So v squared is equal to 36. Finish solving the equation by taking the square root of both sides. So we are finishing up by taking the square root of both sides. Why do we take the square root of both sides? We intend to eliminate the square from the left hand side. So we do the opposite of squaring, which is taking the square root. And you know that we cannot do that on one side of an equation. We will have to do it on the other side in order to balance the equation. And so we take the square root of both sides. So v is equal to 6. Of course, the square root of 36 is equal to 6. And if we do that, then we would have satisfied the requirements of the examiner. Reason being, the examiner said, determine the positive value of v. And we have a positive 36 for our answer. We need not go any further. It is not as simple as that. But square and square root will have a cancelling effect on each other. And the square root of 36 is 6, which is the highlight at the moment. The square root of 36 is 6. There's no difficulty with that. Let us take a closer look at solving the equation. We will solve the equation again, taking a closer look. At this moment, we are going to take a look at the reason for the examiners asking for the positive value of v. We may consider, as on the previous slide, that in order to find the value of v, we need to eliminate the square. So we can go straight ahead and do that. No explanation needed. We explained that already. This we will do by taking the square root of the left-hand side. We know that, and then we need to take the square root of the right-hand side also in order to balance the equation. No problem. Positive value of v. Why positive value of v? The statement asked for the positive value of v as if there might be a negative value also. That is correct. Square roots occur in pairs. Square roots occur in pairs. If we are finding the square root of 36, we have a pair of answers. There is no difficulty seeing that positive 6 is a square root of 36. But let us square negative 6 and take a look at the result. So we square negative 6. When we square negative 6, we are multiplying two occurrences of negative 6. And we know that negative times negative is equal to positive. That will give us also a positive 36. The product of two negative numbers is positive. There are, therefore, a positive square root and a negative square root of 36. Every number that has a square root will have two square roots. One a positive and the other a negative, as we have seen. Therefore, we need to say rightly that v is equal to positive or negative 6. That's our answer, a positive or negative 6. If we solve the equation, v is equal to 6, that will satisfy the requirements of the statement of the problem. However, we are taking a look at the reason for the examiners strictly asking for the positive square root. And the reason for saying that is because the examiners know that there are two square roots. So they are just saying that it is the positive one alone that they want. Only the positive one is required in the statement of the problem, and that is why we say v is equal to 6. If we solve the problem and say v is equal to positive or negative 36, then that's not required by the statement of the problem. So we might not get full marks. It is not that our answer would be entirely wrong, but we would not get the full marks, or we shouldn't, because the examiners only expect the positive one alone. We will take another approach in solving the equation, because that equation needs to just be given a little bit more consideration, which is v squared is equal to 36. Let us subtract 36 from both sides of the equation. What will happen? On the left hand side, we will have v squared minus 36, and on the right hand side, 36 minus 36 is equal to 0. V squared minus 36 is equal to 0. That is our new equation. The left hand side becomes a difference of two squares, and the right hand side is equal to 0. Now we have a quadratic equation that is in the form of a difference of two squares. And that difference of two squares may be factorized, and we might not see the ins and outs of the factorization of the difference of two squares right here, but the factorization of the difference of two squares are all over Richard James Mathematics Resources, on Vimeo, on YouTube, in the instructional manuals, and surely in our tutorial books. So there we have the factorization of the difference of two squares. And we know and we are familiar with the forms of the factors of a difference of two squares, which will have the square root of both terms separated by a positive sign in one pair of brackets and a negative sign in the other pair of brackets. That is how we write down the factors of a difference of two squares. If we have a difference of two squares that we have here, why difference of two squares? This is a square, this is a square, and we have a negative sign, meaning that the expression is a difference of two squares. How do we find the factors? Take the square root of the two terms. In one pair of brackets, we separate them with a positive sign, and in the other we separate them with a negative sign. And of course, we have hundreds of illustrations of difference of two squares in Richard James Mathematics Resources. Positive value of v. Now, what do we do in solving the equation? From the factorized form, it is more obvious that the equation will give two values of v. So when we take the square root of both sides, it might not be so explicit that we will have two values of v, because it's just v squared is equal to 36. V is equal to the square root of 36. One of the square root of 36 is 6. We don't even give consideration to the other one. However, when we have the two factors of a difference of two squares, there is no denying that we will have two values, which are called two roots of the equation, which will be a positive 6 in one case and a negative 6 in the other case. And of course, for more illustrations on this, you go to Richard James Mathematics Resources. We have countless examples, explanation, representations of the difference of two squares. So we are going right back to the requirement of the statement of the problem. Positive value of v. So we are taking the positive value. As we said just now, it is more obvious when we rewrite the equation as a quadratic equation whose quadratic form is a difference of two squares. It is more obvious, and then it is also more explicit that we will have two values for v. The statement of the problem requires the positive value of v. V is equal to 6, and we are finished. In using this method, candidates should know how to solve a quadratic equation by factorizing a difference of two squares. Students, we cannot overemphasize how important it is for your mathematics to be holistic. We are solving an inverse variation problem, and inside there we have a quadratic equation that might be solved by factorizing a difference of two squares. Therefore, it is not a good thing to be picky about the topics that we will study in preparation for an examination, because you might be able to solve a problem in measurements, yet still in the measurements problem there's a quadratic equation that you need to solve by factorization. So although you are keen on measurements, you are not going to get your full marks for the measurements problem because there's a quadratic equation in there and you cannot factorize the trinomial that is there. So it is very important that we study our mathematics in a holistic way. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.